Let's take a look at this example. First, I'm going to find I total. Please notice that we have given sinusoidal voltage, so it means that I have 300 volts peak. Okay, so I'm going to use Ohm's law to find I total. I total is equal voltage source over Z total, and this is my Z total, where voltage source is equal 300 volts, don't forget that this is peak voltage, over Z total, which is equal 1.5 kilo ohms. Okay, so this is equal 200 milliamps. This is not complete answer for my current because I'm missing angle. Angle we are going to find later on. Next, what I'm supposed to do, I'm supposed to simply look what I have given and check what we have calculated. We have given power at the resistor. We have given current. You're supposed to realize that I total is equal to the current which goes through the resistor, and this is also equal to the current which goes through the inductor. Why? Because this is series circuit. So I have two pieces of information at my resistor. I have power and I have current peak. This is peak current because I divide voltage peak by the total impedance. So I'm going to use formula for power to find the resistance. So I have power is equal 1/2 I square times R. Okay, so in order to find the resistance, I'm supposed to simply divide both sides of my formula by 1/2 I square. 1/2 I square. And I'm going to have resistance is equal power over 1/2 I square. This is equal power, true power, 25 watts divided by 1/2 times 200 milliamps to the second power. This is equal 1.25 kilo ohms. Okay, so this is the resistance of my resistor. Next, we can find the inductive reactance or impedance of the inductor. So what we are going to use? We are going to use Pythagorean theorem to do so, because this is series circuit, so I have Z total is equal resistance plus the impedance of the inductor. In order to find the impedance of the inductor, I'm supposed to simply write that this is ZL equals Z total minus R. But please notice that we have no given angle next to Z. Okay, so what we're supposed to do, we're supposed to, as I said before, we're supposed to use Pythagorean theorem. So I'm supposed to write square everywhere and square, square, square. In order to find ZL, I'm supposed to write ZL equals square root, open parenthesis, Z total square minus R square. Let me repeat myself one more time. I'm supposed to write squares next to Z total R and ZL because I do not have angle next to Z total. The angle wasn't given. I'm supposed to find this angle, but in order to find the angle, I'm supposed to find ZL first. That's why I have to use Pythagorean theorem. If you would have angle given, and you're supposed to simply use the calculator to calculate ZL, but at this moment we're supposed to use this method. So I have ZL equals square root, open parenthesis, Z total, which is given 1.5 kilo to the second power minus R, which is equal 1.25 kilo to the second power. This is equal ZL 829.15 ohms and angle of 90 degrees. You are not going to get 90 degrees from your calculator, but you're supposed to always remember that anytime you're looking for ZL, ZL goes always with angle of 90 degrees, or if you want to express this in the rectangular form, you're supposed to write that this is J 829.15 ohms. But most of the time we are going to deal with the polar form, phasor form. Next, we're supposed to find the angle. Okay, we have a formula which says that power factor is equal cosine of angle theta, and this is also equal R over Z total. Okay, so in order to find angle, I'm going to write theta is equal inverse cosine, and I have R over Z total. This is equal inverse cosine, and I have R, which is 1.25 kilo, over Z total, which is equal 1.5 kilo. This is equal 33.55 degrees. Okay, so this is my angle theta, so I'm supposed to write that my Z total is equal 1.5 kilo ohms and angle of 33.55 degrees. So now I can find the angle which I supposed to write next to the magnitude of my current. Now let me explain everything step by step. I total is equal voltage source over Z total. We know that voltage source has angle of 0 degrees, and we found that Z total has angle of 33.55 degrees. We also know that current has magnitude 200 milliamps. We have to find the angle. We're supposed to simply subtract these two values, and we are going to end up with angle negative 33.55 degrees. So this is the full answer for my current. Please keep in mind that I total is equal to IR and is also equal to IC. Why? Because this is the series circuit. Next, we're supposed to find voltage peak across the inductor. So VL peak, I'm going to find by using Ohm's law. Voltage is equal current times the impedance, in this case impedance of the inductor, ZL. We found IL peak, this is equal 200 milliamps and angle of negative 33.55 degrees times ZL, which is equal 829.15 ohms, an angle of 90 degrees. This is equal 165.83 volts, an angle of 56.45 degrees. This is the voltage drop across the inductor, VL peak. Next, we're supposed to find the RMS current which goes through the resistor. We found current peak which goes through the resistor. We're supposed to convert peak value of my current to RMS. Remember the formula? I, R in this case, RMS is equal I, R peak times 0.707, which is equal 200 milliamps, an angle of negative 33.55 degrees times 0.707. This is equal 141.4 milliamps, an angle of negative 33.55 degrees. So this is the RMS value of my current in the circuit. Next, we're supposed to find the power factor. Power factor is equal cosine of angle theta. So I have cosine of angle 33.55 degrees is equal 0.833 lag. Please keep in mind, anytime you have positive angle, right, next to Z total, so it means that the current in the circuit is going to lag the voltage source by certain angle. So that's why we're supposed to write the word lag. In some books we are going to see lagging, other books we are going to see lags. I simply write lag. Why? Because, one more time, the current in the circuit is going to lag the voltage source by a certain angle. Next, we're supposed to find the reactive power, QL. QL is equal 1/2 IL peak to the second power times ZL. One more time, we're supposed to use 1/2 when we're dealing with the peak value of current. So I have 1/2 times 200 milliamps to the second power times ZL, which is equal 829.15 ohms, and this is equal 16.58 volt ampere reactive. So this is the reactive power in my circuit. Next, I'm supposed to find the apparent power. S is equal 1/2 I total peak to the second power times Z total, which is equal 1/2 200 milliamps raised to the second power times Z total, which is equal 1.5 coulombs, is equal torre volt ampere. So, if you want to draw the power triangle, you're supposed to simply draw the true power, which is equal 25 watts. Next we have QL, QL is equal 16.58 VAR, and apparent power S, which is equal torre volt amp, and this is my angle theta. We found the currents, impedances, powers, so we can say that the problem is solved.